Hello, I am Hongsup So and I am developing Mainnet and I'm the leader of my team. And I'd like to talk about how we secure transaction data in account-based blockchain. This is the main agenda for today's presentation. First, I'd like to talk about privacy-enhancing technologies, and I'd like to explain about the difference between UTXO and account. And I'd like to introduce the solutions that LINE Blockchain team uses and future plans. But this is the first question that I want to ask you. Why should the transaction be hidden? Anyone can see and verify all transactions transparently on blockchain. Blockchain is resilient and decentralized, and there are some requirements from services that want to protect personal information while using those features. So these are the requirements that we found out. First, they wanted to protect personal information. We have different understanding about personal information. It's not just birthday or phone numbers, but any information that can be inferred from someone is treated as personal information. So for services that require privacy protection, they also want to protect transaction information. Second, for the security of wholesale transactions of trusted institutions, transactions should be hidden. Transaction should be hidden. If it's not, it's difficult for the big institutions to implement important policies that require institutional security. For these reasons, we started developing at LINE Blockchain. So let's take a quick look at the techniques that can be used to hide transactions. So it may be very hard to understand, but let me try to explain the concept as simple as possible. So listen attentively, please. According to the report of Project Stellar in 2020, here are the 3 privacy-enhancing technologies: segregating, unlinking, and hiding. First, segregating. Segregating is a technique that transaction information can be known between transaction parties, but the information cannot be viewed by third parties except for the transaction parties. So there's ledger segregating and off-chain payment channel. Ledger segregating is a technique that blocks third parties' access to transaction information itself by recording transactions on a ledger shared only by the transaction parties or related parties. So when ledger segregating is applied, it is difficult to apply if you want to use the same distributed ledger method because each individual ledger is created for each transaction. An off-payment channel is a technique that records only the transaction start time and transaction end time in the ledger when multiple transactions occur frequently between specific participants. And all transactions that occur in the middle are processed outside of the ledger. Since assets do not move on the actual ledger during the transaction, a device such as escrow is required to prevent the transaction from being stopped or the balance running out. And trust between the transaction parties is required. And second, unlinking. This breaks the relationship between the sender and the receiver of the transaction or transaction amount so that the transaction information cannot be inferred from the transaction information, including one-time address, mixing, and ring signature. One-time address is a technique that uses a new address every single time when a transaction is made. So it's difficult to understand the relationship between the actual user and the address and the transaction details. And mixing is a technology that makes it difficult to match senders and recipients by tying and processing multiple transactions of the same amount. If the amount is different, we split the transaction so that it can be made into the same amount so that the transaction can be mixed. Ring signature is a technique that hides the sender of a ring signature that collects the public keys of several users and uses them in a transaction, unlike a general digital signature that uses only the sender's public key. Third is hiding. and it hides some or all of the sender's, receiver's, or transaction amount in the transaction information. There are Peterson commitment, zero knowledge proof, and homomorphic encryption. Peterson commitment is a technique of commitment scheme. Commitment scheme is a cryptographic method in which the sender does not send the value itself to the receiver, but encrypts the content and later shares the decryption key to confirm the content. So here, Peterson commitment uses the cryptographic method of the elliptic curve to perform additional operations, even in an encrypted state, so that the validity of the transaction can be verified without disclosing the transaction amount. In blockchain, it's mainly used to hide the transaction amount. And zero knowledge proof is an algorithm that allows verifiers to share and verify evidence proving that they know that information that they are hiding without disclosing the information that they are trying to hide. So it is a good algorithm to hide all the information on the transaction and prove it. Homomorphic encryption is an algorithm that enables a four-way operation of additional multiplication while data is encrypted. But this is not fast and efficient enough to be used on blockchain, so it's not used in blockchain yet. However, as technology advances, I guess it can be used in blockchain in the near future. So LINE Blockchain development team is also researching it so that we can use this in the near future. This is the summary of PETs. So you can see what kind of information can be hidden for senders, receivers, and amount. There's a difference between the techniques, but you can only hide parts or all. So it feels like, so you don't have to understand everything, but you can just refer to this table so that you can know what can be used from this. Please remember this table. We will be explaining about what we used for LINE blockchain. So there are two main types of transaction processing methods in blockchain, UTXO and account. So we have UTXO-based and account-based. So blockchain can, Bitcoin is a key UTXO-based blockchain and Ethereum is an account-based blockchain. Since you can choose to make a secure transaction depending on the transaction processing method. So let me tell you about the definitions and differences of each. For your reference, LINE blockchain uses account-based blockchain. UTXO stands for unsent transaction output, and it is an object containing owner information, usage status, and balance information. So with a private key corresponding to owner information contained in UTXO, you can provide the use of ownership of the UTXO and create and trade UTXO that delivers the UTXO that you own to the new owner. So you can see on the left, we created two UTXs, and this is how the transaction is made on UTXO. And if you look at TXK plus 3, you can also make one transaction by proving the ownership of these. And at this time, the input UTXO used in the transaction are marked as used after the transaction is completed, and it cannot be used as an input for other transactions. So UTXO is like a currency, like $1 and $10 individually, and it's like summing them up. UTXO disappears once used, so it has excellent anonymity and security, and it can be scalable because each UTXO object can be processed in parallel. But in order to know the owner's asset holdings, you have to have the owner's list of all UTXOs, and chain needs to store and manage UTXO. It takes a lot of storage. Account model is a model that manages the balance information based on a user account like a bank as a key and value type database. So for a transaction, the amount less than the balance held by the sender is the remit transaction amount, and the transaction is signed with the sender's private key. So in other words, UTXO proves ownership, whereas account model proves there is a balance. And when the transaction processing is done, the balance of each account is changed to reflect the transaction result. since the contents recorded in the transaction are directly applied to the state value operation, complex processing can be written intuitively and it is easy to understand. So it is easy to implement smart contracts. But performance improvement through parallel processing is not easy because the account balance is a critical area. So I've told about the pros and cons of and the differences of UTXO and account. So here's the table. For transaction, UTXO consists of input, output, lock, and unlocking script. And UTXO is based on who the owner is. And for account, it's comprised of sender, receiver, amount, and signature. And it checks the sender's balance if it's sufficient and the signature is valid. And for recording the state, UTXO, the movement of asset is directed acrylic graph. And the owner's balance is the sum of all the UTXO. Unlike UTXO, account, it's recorded as key and value database of network states. And you can just see the balance by just checking the account balance of a user. So here are the advantages and disadvantages of UTXO. UTXO has parallel processing and it's easy to implement sharding and excellent anonymity and security features, but account has these advantages. And also for UTXO, disadvantage is that smart contract designing is complex and it's difficult to do parallel processing in account and you need to prepare a plan to prevent double payment. Due to the differences in the way the UTXO model and account-based model stores data, there is also difference in privacy-enhancing technologies that can be used. UTXO model is stored in the form of a directional acrylic graph, as shown in the left. And while retaining the unique information in the form of an object when the UTXO is created as a way to store the state. So since you need a simple proof of ownership to use UTXO, you can secure only a specific UTXO so that only the transaction party can verify it. However, since the balance of the account model is managed in one variable and balance is continuously updated, it's necessary to manage a public balance and other security balances as separate variables in order to secure only certain transactions and make them known only to the account party. And in order to change the value of the security balance, whenever the state changes, you have to be able to use homomorphic encryption or like that. So did you understand that? I hope. So in summary, if the UTXO 5 on the left is secured by state in the UTXO model image, no matter which technology you use, you just need to prove that you own UTXO 5. However, if you want to make a secure transaction of balance T2 of account A in state n plus 2 of the account model on the right and reflected in state n plus 3, you need to prove why balance T2 of the account A is valid balance in state n2. However, since the balance continues to be reflected by previous transactions, you need to be able to prove previous transactions as well. So, in order to make only certain transaction in account model, a separate balance for security transactions must be managed as a variable, and this balance must be encrypted and computable. Did it even get harder to understand? Well, anyway, the account-based blockchain is a little more difficult to implement security transactions than UTXO-based blockchain. So you just need to remember that. Previously, we took a look at the techniques that can protect personal information in the blockchain and how it handles transactions. Now you are a security expert in blockchain. Then let's now find out which technique LINE Blockchain is using. LINE Blockchain already have a developed mainnet and has a separate consensus algorithm, and it adds a security transaction function to its mainnet. So there are some things that we need to observe and be careful. And in addition, there are also functions necessary for LINE Blockchain. So I summarize the requirements. First, both public and secure transaction has to be possible. So most transactions are open transactions that have already been implemented, and all of the senders, receivers, and transaction amount are disclosed. But special services or special transactions should be able to make secure transactions. Second, all public and secure transfers must be public on a single ledger, and all nodes should have the same ledger. This is because it is difficult to verify and agree without changing the currently developed consensus algorithm in the case of divided non-identical ledger. And third is that all the secure transfer must be secured by the sender, receiver, and amount. So this is the ultimate method that we want for secured transaction. And last, secure transfer needs to be auditable by auditor. So it means that even if the sender, receiver, and transaction amount are all secured, it will not be used in general cases, but if an authorized person requests an audit, the ability to audit the transaction is required. So this function is not essential, but it was an optional requirement depending on the situation in which the blockchain was used. To meet the requirements, we have checked the applicable techniques among the technologies that we've looked at earlier. So for the second requirement, segregating cannot be applied. Segregating cannot be applied because not all ledgers are open to all users and all nodes, but are segregated into private and public ledgers, or segregated so the only trading parties can see them. And in order to satisfy the third requirement that all transaction contents be processed in a secure transaction, we can select between these two, but ledger segregating does not meet the second requirement. So we had to go with zero knowledge proof. However, of course, all information can be secured by using mixing and ring signature or mixing or Pedersen commitment, but we decided to use zero knowledge proof to speed up real-time transactions and confirmations. I've briefly mentioned about zero knowledge proof. Before I explain about the implementation, let me talk a little bit more so that you can understand better. The most commonly used example when explaining about zero knowledge proof is the Alibaba's cave. So you have this way to go to A or B, and this is blocked by a door. And just like the image on the left, Bob is waiting outside the cave, and Alice has to choose either A or B, and Bob has to come into the cave and tells Alice to take one direction. If Alice comes in the same direction, it means that Alice has the key to open the door. So it means that if Alice goes in and if Alice comes out, Alice can come out, but without any discussion, if you do it repetitively, you cannot be lucky all the time. But if Alice only comes out of the direction that Bob knows, it means that Alice has the key to opening that door. So it means that Alice doesn't have to say the message that opens the door, and it's an easy understanding of zero knowledge proof. So the information can be hidden with a cryptographic method, and the validator can validate it. So if you use zero knowledge proof, you can validate it with an encrypted method. So I will just call it as ZKP for shorten it. We use ZKP on LINE Blockchain. And as we saw earlier, the balance is continuously updated. So we have to have a technology that can add even in an encrypted balance is required. So for this, we can use Pedersen commitment. But just like the first requirement of LINE blockchain, it had to have public and secure transactions, and the conversion between the public and encrypted balances must be possible and verifiable. But it was not easy to implement this with Pedersen commitment. So after a lot of thought, we decided to use a hybrid model that uses the UTXO model for balance used in secure transaction without changing the public transactions, and the account model for balance used in public transactions. So we made it possible to use both the advantage of the account model and the advantages of UTXO model. In order to satisfy the fourth requirement that a secure transaction should be audible by auditor, the security balance used in the secure transaction is encrypted with an encryption key and a viewing key pair, which is different from the signing key, to prove ownership. So main functions of the LINE blockchain implemented while satisfying these requirements are the following four. First, add secure transfer, and all secure transfer are handled with zero-knowledge proof. Security transactions are verifiable with evidence without disclosing both the sender-receiver transaction amount as zero-knowledge proof. Second, secure transfer is a UTXO model and public transfer is account model. So we use the merits of both UTXO and account model. So we can implement it without changing the previously implemented smart contract or consensus algorithm. Third, transactions between secret and public balances. So it should be able to be transferred freely. And finally, encrypt UTXO of secure transfer with one-time encryption key. So we made it hard to infer the owner of the encrypted UTXO by creating a new encryption key for every secure transaction. In LINE blockchain, secure transactions are made on a secure balance, which is UTXO model, but basic transaction takes place in account model. So the public balance, so an exchange between the public balance and the secure balance is required. So that's why we had to have hiding transaction and revealing transaction. And we also needed to have a secret transaction. So let's take a look at how transactions between secure and public balances are made. In LINE blockchain, hiding transaction is used to transfer the public balance, which is the balance of the account-based method, to the secure balance, which is UTXO model. In hiding transaction, the sender and transactional amount are disclosed, and by adding to the transaction, but the recipient information is not added, and the signature of the sender is also added. So when the hiding transaction is received on the chain, it first verifies the sender's signature and balance, and then it verifies the ZKP proof of the secret UTXO that the receiver will own. If it is confirmed as a normal hiding transaction request, the amount of the transaction amount is deducted from the sender's public balance, and the deducted transaction amount is burned. And with the balance equal to the amount of the burned transaction, the owner creates a mint UTXO and the sender and treats it as a transfer of ownership from this mint UTXO to the secret UTXO. So in other words, the public balance is burned by the amount of the transaction and a new security balance is issued. Since all information in mint UTXO is public, the balance of the secret UTXO whose ownership has been transferred can be inferred. However, so we cannot know who the owner is, and the secret UTXO is split or combined into another secret UTXO during the corresponding secure transfer in the next transaction, so the information on the balance can no longer be tracked. Unlike hiding transaction, Sending from secure balance to public balance is done through revealing transaction. And in this case, the transaction amount with the receiver is added to the transaction without the sender's information, and the proof of ownership of the input secret UTXO owned by the sender is included in the transaction as evidence calculated by zero-knowledge proof. And when the chain receives revealing transaction, it checks whether the secret UTXO is used or not and verifies the evidence of ZKP. If it is known to be a normal revealing transaction, burned UTXO is created and burned, and as much as the transaction amount is added to the public balance, and the public balance is created by the amount and added to the public balance of the recipient. However, in the case of a transaction that remains the entire balance of an input secret UTXO, the burned UTXO is disclosed, so the balance can be inferred. So in this case, if only a partial amount, not the entire amount of the input secret UTXO is transferred to the public balance, and the remaining balance is generated as the output secret UTXO, and it may be difficult to infer the balance information of the input. So in this way, revealing transaction is the UTXO model, and so that the recipient and the transaction amount are publicly known to anyone, but the sender is unknown. And transactions between secure balances are processed through secret transactions. So if it is a transaction where we can proceed with this transaction with the sender, receiver, and the transaction amount that we all want as private. So in secret transaction, the sender's receiver transaction amount are all private, and the owner of the secret UTXO on the secure balance are generated as evidence by ZKP calculation. The chain verifies whether the secret UTXO included in secret transaction are used, and the ZKP evidence is verified, and if it's verified to be normal, the input secret UTXO is converted into a used UTXO, and output secret UTXO is recorded as a newly usable UTXO. So this enables secure transactions in which all information is kept as secret. Of course, it is also possible to send money from one secret UTXO, but by proving ownership of multiple secret UTXO, secure transactions with one or two secret UTXO as output are also possible. So I've talked about the process of secure transactions. When this happens, illegal transactions can also be made through illegal funds implicitly. So to prevent this, for the secret UTXO included in the transaction suspected of being an illegal transaction, the information of the transaction can be audited by requesting the viewing key. However, only the corresponding secret UTXO can be checked with the shared viewing key, and other secret UTXO cannot be checked. If you want to be audited by a central bank or trusted authority, secure transactions can be audited if the encryption key and viewing key are designed to be managed by a separate trusted auditing entity. So now, do you have a good understanding of secure transactions in LINE blockchain? To summarize, a general transaction is a public transaction in which all transaction information is disclosed through transaction. This is the basic transaction method of public LINE blockchain. However, if you want to keep a certain balance private, you can request a transaction with hiding transaction from sending party and receive it as a secure balance. Of course, you can also convert it to a secure balance by using hiding transactions for yourself as well. And this secure balance is now available for secure transactions with a secret transaction. And you can then convert it to public balance if you need by using revealing transaction. So a method of creating a secure balance from scratch by a trusted institution such as central bank, so that all transactions can be made as secure transactions, is planned to be further developed in the future. After reviewing many papers and going through a lot of trial and error, we did a POC of a technology that meets the requirements of LINE blockchain, but we currently have basic features, but we want to make the basic functions that we developed to be improved. So this is our future plans. We plan to provide and we want to support NFT secure transfer as well. So we plan to add NFT ownership and transfer to be enabled. Secondly, the current securities transaction audit requires a viewing key to be requested from the owner. And if the owner loses it, there's no way to audit it. So to improve this, we are considering MPC, a method in which multiple auditors, including owners or audit systems, can each utilize all unshared inputs to compute the same result. And it's called MPC. Of course, we are reviewing many things. So if you have good ideas, please let us know. Third, the transactions of secret UTXO on chain depend on the proof of zero-knowledge proof. Of course, there is no problem with the current method, but we plan to introduce homomorphic encryption to make the encrypted information verifiable so that even the encrypted information of the secret UTXO in the chain can be verified. I've explained about a very hard concept, which is security transaction in blockchain. And thank you so much for listening. And we are making continuous efforts and researching to make blockchain more convenient for you to use. Thank you, everyone.